All right, class, this is 2.1 guided reading part B. So here's the part this is still about volume. So in case you're wondering what the topic is still volume. This right here is a graduated cylinder. We have a certain amount of liquid. What does the line point to? Write your answer to the space provided. So this is how we measure liquid, the volume of liquid, and if I'm looking at this, the bottom of the meniscus, which is something you should have already have had a vocab card about, comes up, the bottom of the meniscus of the liquid comes up to, if this is 40 right here, it comes up to 44. And this is measured in milliliters, so it's 44 milliliters. That's what a graduated cylinder measures in. You can see that up at the top there. Okay, so there we go. So now you can see what's going on. Now, milliliters, 1 milliliter is also equal to the same thing, is called a cubic centimeter. That's when you have a box that is 1 centimeter by 1 centimeter by 1 centimeter, okay? And when we multiply all three of those, then we get 1 cubic centimeter. So it says circle the letter of each unit used to measure the volume of the solid object. So we measure typically in centimeters, or we can measure also in meters if we're measuring, where are we at here? To measure the volume of solids with larger volumes. That means we can measure with a cubic meter. So cubic meter or cubic centimeter. Either one works very well. This says what formula is used when we measure a regular solid. Typically we use volume equals length times width times height. There must be 3 parts to that: length, width, and height. Okay? The following sentence is it true or false? One method used in measuring a volume of an irregular solid involves immersing the object in water. Yes, that is true, actually. It is true. And we call that water displacement. Measuring volume by water displacement. Oops. E-M-E-N-T. Good. Excellent. All right, let's move on. We got a couple of things here. What's density? Density is the measure. There we go. Where are we at here? Density is the measure of how much mass is contained in a given volume. So you could put that in right here. And what is the formula used to calculate the density of an object? You can see this formula right there. So that would be density equals mass divided by volume, which means that we have mass typically in grams and volume in milliliters. Okay, that's what the units of density are. Let's keep going. Circle the letter, and I just did this. Circle the letter of each common unit of density. So for a common unit of density, you must have a mass and then divided by a volume. Grams is mass, milliliters is volume, so A is 1. Cubic grams, there is no such thing, so we don't have that. Grams per cubic centimeter. Cubic centimeter is a volume also, so grams over volume. So that would be a yes, and I screwed that up like that. And cubic centimeter is a volume but not a density. Okay, what is density of an object with a volume of 20 centimeters and 40 grams? So that would be 40 grams. Remember, D equals mass divided by volume. 40 grams is the mass, and 20 centimeters cubed is the volume. So that means 40 divided by 20 is just 2 grams per cubic centimeter, like that. Is the following sentence true or false? Density of a substance is the same for all samples of a substance. So it says The density of a substance is the same for all samples. I got that right here. Okay, so that would of course be true. An object will float if it is less dense than the surrounding liquid. Okay, that is true down here. I'm going to keep moving through here pretty quickly. Time was the SI unit measurement for this. That is seconds. Time is seconds, and 1 second equals 1,000 milliseconds. Good. Keep moving. Temperature. Temperature scale the scientists commonly use. Scientists commonly use the Celsius temperature scale. Okay, so that would be degrees Celsius. What's the official SI unit for temperature? However, the official SI unit for temperature is Kelvin. Okay, circle each of the sentences that's true about the Kelvin scale. The Kelvin scale has no negative numbers. That is true because the Kelvin scale starts down here. At 0 Kelvin is the lowest possible temperature. It says that right here. Is a temperature that scientists consider to be the coldest possible temperature. Absolute zero is equal to a negative 273 on the Kelvin scale. No, that's not true. Nothing can get colder than 0 Kelvin. That's true. And water boils at 373, and that is also true. Water freezes at 273 Kelvin because that's equal to 0 degrees Celsius. So that means that 373 Kelvin is equal to 100 degrees Celsius. And that's the boiling point, so that's correct. Good. Moving on. Now converting. An equation that shows how 2 units of measurements, let's go to my highlighter here, are related is called, convert from one measurement to another, you need to know the appropriate conversion factor. That's what we need. How many grams is there in 1.5 kilograms? Well, that would be this problem here. My conversion factor is 1 kilometer, is equal to 1,000 meters. So that means over here that if I have 1.5 kilograms, right, over 1 times, and then I have 1,000 grams, that's a G, for 1 kilogram, because 1 kilogram equals 1,000 grams. Okay, that means that I have 1,000 times 1.5 is that number of grams. Good. Well then, how many grams are in 0.450 kilograms? So I multiply that by 1,000 grams, like this, over 1 kilogram. And that equals, notice I can cancel the kilograms. I'm screwing up stuff here. So 0.450 times 1,000 is 450 grams. I'm going to let you figure out how to do the last one at 7.25 kilometers. Okay, you're going to use the same steps that we did for this. Good luck. I hope you do well.